Alright, let's start off with a quick tutorial on a problem that uses transformers in order to figure out what sort of voltage you're going to get whenever you have a primary and secondary coil within a transformer. So just to review, a transformer is a device that allows for voltage to either be stepped up from a lower voltage to a higher voltage or to be stepped down from a higher voltage to a lower voltage. And the application in this case is how you get voltage or current, electricity, to your house. Electricity comes from a substation at a much higher voltage than what we have in our households. So the transformer, which is on a pole in your neighborhood, steps this voltage down to the 120 volt voltage that we use in our homes. Well, let's try something out here. Here we're looking at another case of using a transformer. And the wording of the question is this: a voltage of 120 volts is put across a primary coil with 60 turns. If this voltage is going to be supplied to a device that uses 12 volts, how many turns must the secondary coil have? So just to sort of put this into context, why it is so important. Why do we need coils? Transformers work on electromagnetic induction. That is, the electricity flowing through wire coils will induce a magnetic field. This magnetic field, if it's run through another coil, will, since it is changing, right, we're creating a magnetic field, it's going to induce a voltage in the secondary coil. So here we go. Let's put this to work. So first of all, let's talk about what we know. We have information about the primary coil right here. So we're also going to use this nice little equation. All right, so from this particular question, we're given the primary voltage, and we're also given the number of turns in the primary coil. So primary voltage is equal to 120 volts. The number of turns in our primary coil. So number of turns in primary is going to be equal to 60. 60 turns. So what do we know about the secondary coil? Well, what we know from the secondary coil is the secondary voltage. So secondary voltage is going to be equal to 12 volts. Of course, to save a little space, I'm going to abbreviate secondary here. Secondary turns. All right, do we know that? Well, if you look at the question, what it's asking here, how many turns must the secondary coil have? That means we are solving for the number of turns in the secondary coil. So let's go ahead and set this up. So we have 120 volts divided by 60 turns equal to 12 volts. And we don't know what that is. We want to solve for the number of turns in the secondary coil. All right, so let's solve this equation. So to do this, we'll have to multiply both sides by the number of turns in the secondary coil. So we're looking for this. So our question mark times 120 volts, all that divided by 60 equals to 12 volts. All right. Now, follow the little arrow here, and we'll continue this over on this side. So now what I need to do is to get the number of turns on a side by itself. And so what I'm going to do is divide both sides by 120 volts. And multiply both sides by the number of turns, 60 in the primary coil. I'm 60. All right, so wonderfully enough, volts cancel. whenever we crunch the numbers here, we find that the number of turns is going to be equal to 6 turns. All right, so 6 turns is our answer here for determining the number of coils that this secondary coil must have in this transformer.